Hi. Welcome to Reyes Company. I'm Gianfranco A. Reyes from BSCS 3D, and we will be discovering encryption, decryption and hashing. We all know hundreds of people uses internet. And with the use of the internet, we exchange a lot of private data by using any of our devices. So how can we keep these data a secret? These data will be kept secret through the process of encryption. Through the process of encryption, it makes the readable information into a not readable information. In other words, it's scrambling the letters to hide its message. In this case, it cannot be stolen by cybercriminals when the information is sent into another device. So, what is encryption's main goal? Encryption's main goal is to safeguard data from an unauthorized individual who wants to read or obtain information from a communication that was not intended for them. So, encryption improves its security. Now, how about decryption? Decryption is the process of transforming data that has been rendered unreadable through encryption back to its unencrypted form. In other words, it's unscrambling the message to make it readable. Take a look at this. In decryption, the system extracts and converts the garbled data and transforms it to texts that are easily understandable. Decryption may be accomplished manually or automatically. It may also be performed with a set of keys or passwords. What is hashing? Hashing is the process of utilizing a hash function to turn data into a key. By any means, the original data cannot be recovered from the hash key. Generally, the hash keys are stored in the database and they are compared to check whether the original information matches or not. They are generally used to store the passwords for login. Difference of encryption, decryption and hashing. In encryption, it is a two-way function. It means that the information is converted into a non-readable information and can be converted back into a readable information. While hashing is only a one-way function that changes a plain text to a unique digest that is irreversible. We have here an examples of encryption algorithm. First is the DES symmetric encryption algorithm. DES converts 64-bit blocks of plaintext data into ciphertext by dividing the block into two separate 32-bit blocks and applying the encryption process to each independently, which involves 16 rounds of various processes, such as expansion, permutation, substitution, or an XOR operation with a round key that the data will go through as it's encrypted. Another is the 3DES symmetric encryption algorithm. 3DES is an upgraded version of the DES algorithm that was released. It applies the DES algorithm thrice to each data block. As a result, this process made 3DES much harder to crack than its DES predecessor. It also became a widely used encryption algorithm in payment systems, standards, and technology in the finance industry. It's also become a part of cryptographic protocols such as TLS, SSH, IPsec, and OpenVPN. Next set of example will be the hashing algorithm. Tiger algorithm. It is a new and fast algorithm. It used by modern computers. It hashes more than 132 mbits per second. It has thus far proved to be more efficient than all the hashing algorithms discussed. It has no restrictions on its usage, that means it has no patents. Whirlpool algorithm. It takes as input a message with a maximum length of less than 2,256 bits and produces as output a 512-bit message digest.